Dear students, welcome to part 2 of module 5, Design of Machine Elements. My name is Harikrishnan C, Assistant Professor, Mechanical Engineering Department, Rajagiri School of Engineering and Technology. In this lesson, we will be discussing about problems from flat belt as well as V-belt design. Here we have the first question. A flat belt drive is required to transmit 20 kilowatt of power at 1440 rpm. Driver and driven shafts are approximately some distance, and dimensions of the pulley of two shafts are given, and weight density of the selected material is given, allowable design stress is given, and coefficient of friction is given, and they are asked to the fundamental dimensions of belt and initial tension and centrifugal tension of the belt. Here, for solving this problem, we have equations that we discussed in the previous class of part 1 of the module 5 that you can refer. There are some common equations we are following. Everything is every parameters are directly given. You have to simply substitute that values and you can find these 4 parameters. In this problem, the power is given and speed is given, center to center distance is given, diameter is given, diameter of the small and larger is given, and weight density is given, the sigma d is given, friction coefficient is given, and the thickness is given. First, we have to find the width of the belt. For finding the value of width, we have the equation connecting the P and B. From that B value, you can find this value B. For finding this value B, you have to find the velocity. This velocity is here. You have to substitute the value of velocity here. We have the fundamental equation pi dn by 60, and in that we have to calculate or consider the case of thickness also. Pi dt plus d plus t into n by 60. Substitute that value, you will get the velocity. And we have a thumb rule. If the velocity is greater than 10 meter per second, we will consider the effect of centrifugal tension Tc, and that here the velocity is greater than 10 meter per second, so you have to consider the effect of centrifugal tension. And from the equation P, you have this equation. Here you have to find the theta value also, and theta value can be calculated by equation pi minus capital D minus small d by c. If you remember the derivation, this is the equation for finding the theta s, the wrap angle, and P is equal to 20 is equal to P is given, here's 20 is given, and substitute that value here. Every parameter other than B is given, and substitute that value. We can easily obtain the value of B. Here theta s is equal to pi minus d by c. It is given as 14.1 in our data book, page number 289. And here you can obtain the value of width as 162.25. In our data book, there's a table 14.9a. There you can find the value of standard width. It is seen in between a value of 160 and 180. Here you can obtain the select the value of 180 from here. To find the length of the belt, you have the equation. For that equation, you can all the values are given, pi into capital D plus small d by 2. So here you can have the equation for L, that is from 14.2b in the page number 290. Substitute that value and you can obtain the equation for value for length of the belt. Here we will be assuming that it has open belt reason. Here we have the value theta is equal to 3.092, and substitute the value and convert it into angle. It will be obtaining in the angle in degrees as 177.04. It is less than 180 degree, hence you will consider this as an open belt. We studied about open belt and cross belt in the first part video. Please refer that video for more details. And to find the centrifugal tension, we have Tc is equal to the 14.3 E equation. In that equation, you have to substitute these values. you will get TC value, the centrifugal tension value. And to find the initial tension T0, you have three equations connecting, two equations connecting, T0. T1 plus T2 is equal to root T0, that you will get that value. For finding T0, you have to obtain T1 and T2. That equation can be find out from by solving these two equations. This is the fundamental equation and this is 14.3c. By using these two equations connecting T1 and T2, solve these two equations and find the value of T1 and T2. You will get T1 as 2003.5 Newton and 1136 Newton as T2, and these two values substitute here, you will get T0. This is the steps for first question. The common design procedure for flat belt will be discussed with the help of this slide. Here, as we design in the case of gear and clutches, we have some following rules are there. First, we will consider the preliminary decisions. First, we will consider or design the material of the belt. Generally, leather is used as a belt design material, and generally oak tanned or mineral tanned leather with the sigma D value 2 megapascal is used. Then we will select the material used for pulley. Generally cast iron is used because of the damping property. And next we will select the type of joint required, either with the cemented joint with the eta j is equal to 100%. Generally we will consider the cemented joint. Here we have a table there that you can use for finding the type of joint 14.5. And next we will consider the service condition CS. 1.2 is used in general. Service factor CS is equal to C1 C2 multiplication of C1 C2 C3 C4 and C5 different service factors. Then we will calculate the design power PD. PD is equal to P. The modified P value is equal to P into the service factor. And the first stage is the preliminary decision. That preliminary decision we will consider the main 5 cases. And next we will consider the diameter of the smaller pulley. The Savarin empirical formula is used for finding the diameter of the smaller pulley. And we have the equation 14.9a for that. And then we will consider the diameter of the driven pulley. After considering the slip of the belt, we will be having that equation in 14.9b where we have the epsilon value is 0.01 to 0.03, coefficient of creep, and I is the velocity ratio. And we have the standardized pulley parameters that we can obtain from 14.13b. Just to refer the table 14.13b. There you have the standardized belt pulley dimensions that we had done in the previous problem. And next we can calculate the belt speed. This is the equation for that, and determination of the center distance. That is also available in our data book. And determination of coefficient of friction, Bath formula that we discussed in part 1 of the video, and determination of the length of the belt that we discussed, the both angle and length we discussed in the previous problem. Then the width of the belt, that also we discussed in the previous problem. Determination of T1, T2 and T0, that things we done in the previous problem. Next problem, problem 5.2. This is a homework for you, and we will discuss the problem here. A horizontal drive is required to drive a compressor by means of an electric motor. Select a suitable flat belt drive from the following details. Power is given, slip value is given, is 2.5%, it's equal to 0.025. Speed of the motor pulley driver NS is equal to 1400 rpm, and the service factor CS is equal to 1.2, sigma D is equal to 2 megapascal, and eta J, the efficiency of the compressor, is equal to 90%. Speed of the compressor driven NL is equal to 500 rpm. As we discussed in the previous slide, first we have to do the preliminary decision. First you will consider sigma d is equal to 2 megapascal, and assume the pulley is made of cast iron, and eta j is given, it is 90%, and service factor cs is equal to 1.2, and design power cd is equal to p into cs. That is the first step. Then you have to find the diameter of the driving pulley. That is by using the equation d is equal to 630 cube root of pd by w. That is available, this equation is available in our data book. And we have to find the diameter of the pulley, capital D, using the equation capital D is equal to 1 minus epsilon into d into I. Then you have to standardize, and you have to find the belt speed using equation V is equal to pi dn into 1 minus epsilon by 60, and center distance c greater than or equal to 2 into capital D plus small d. Then coefficient of friction using the Barth formula, and length of the belt using our the basic equation that we derived in the first video, and angle of contact, and then the width, that is also we have an equation that you have to substitute. And for finding the tensions, similar to the previous question, that we can use the equation of T1, T2 and Tc, substitute that value, we can find T0 and Tc. This is a step that you have to do as a homework, and this question we will discuss in this video. This question deals with design a flat belt to drive a winch from an electric motor of 12 kilowatt having a speed ratio of 3. Speed of the motor shaft is 900 rpm. Assume a service factor of 1.5. This question is little lengthy question. First we have to note out the given parameters. Given the power is given as 12 kilowatt and I equal to 3. It is given speed ratio, and the motor speed of driver n is equal to 900 rpm, and cs is equal to 1.5. Let us go to the solution of this problem. Just to consider, this is a standard procedure is used for solving the belt problems. For solving this problem, we have power is given, and I is given, the speed ratio is given, and motor speed is given, cs is given. Like we discussed in the previous slides, we will be considering the preliminary decisions first. First we will assume that the belt is made of off-tanned leather with sigma d is equal to 2 megapascal, and next we will consider the case of pulley material. It has cast iron, it is having good damping property, and then we will consider the belt is made of endless at the factory by means of cemented joints, which is having an efficiency of 100%, which can be obtained from the table 14.5 of page 307 in our data book. And we will consider the given service factor 1.5, and the design power PD is equal to P into CS. And for finding the diameter of the driving pulley, we have the equation 14.9a 630 cube root of 3 PD by W max, where W max is equal to 2 pi n by 60, that you can substitute and find the value of small d, and you can obtain the standard dimension from our the standardized table 14.13b, and substitute the value for the standard value for the diameter of the driven and driving pulley. And next we can obtain the standard sizes from that table. After that we will find the belt speed. For finding the belt speed, we have a standard equation that we discussed in the previous slide, and center distance, that's also we have a standard equation 14.2d. Then coefficient of friction, we have the Barth formula, then substitute that value, we can obtain mu value, and length of the belt we can calculate by 14.2b, that is 99.25 mm. Then we can calculate angle of contact for the smaller pulley and larger pulley using the equation 14.1a, and using that we can find B value, the width of the belt, where power and the width of the belt are related by the equation P is equal to BTV by 1000 into sigma d minus WV square by 10 raised to 6 g. e raised to mu theta minus 1 by e raised to mu theta into eta j. Here eta j we assumed as 1. Assuming this leather factor rho is equal to 1000 kilogram per meter cube and weight density W is equal to 9810 Newton per meter square for leather. And for motor pulley, mu s theta s is equal to 1.46. For winch pulley, mu l theta l is equal to 1.7. For these values, comparing these values mu s theta s and mu l theta l, we will design it based on the smaller value 1.46. We will design for the motor pulley and substitute that value. We have 18 is equal to bt into a known equation. Then we will obtain bt is equal to 765. In belt design, we are using a thumb rule. It is b by t is less than or equal to 50. Here consider this equation, there is a less than, please consider this as less than or equal to 50. Then t is greater than or equal to 0.02 and substitute that value. You will obtain the value of t from this equation, and that yields b is equal to 765 by 8. This is that equation. Using this equation you can find t, and using this equation substitute t here and find the value of b. Now we have to find the standard value of b from the table 14.1, and similar to the previous questions, we will find the belt tensions. We have mainly three equations connecting this power equation, and T1 minus Tc by T2 minus Tc equation, and the initial tension equation. For finding the initial tension, you have to find T1 and T2. You can find the T1 and T2 using these two equations. Solving these two equations, you can find T1 and T2. Substitute these two values and find T1 and T2, and using T1 and T2 you can find the initial tension. This is the final answer. T0 is equal to 9841 4.12 Newton. Here we are stopping with flat belt and we are starting a new area, V belt. Here if you are using a V belt, when we are using a flat belt, there are chance of some disadvantages are there that we discussed in the first slide. And here if you are using the V belt, there we have many advantages: higher force of friction, short center distance, higher speed reduction, endless belt, that means efficiency will be high, negligible slip, and can operate in any position. And if you are using a V belt, the bending stress will be more. It is not as much flexible comparing to flat belt, so chance of bending stress is there, and lesser efficiency, and complicated and costlier. This fabrication is little costlier, so the V belt is costlier than flat belt. And the design procedure for V belt, this is very similar to flat belt. First we will consider the preliminary decision, material of the pulley. Normally the CI is used, cast iron is used because it is having good damping property. And then we will find the type of joint using the table 14.5, and service conditions KS, and calculation of design power P into KS. And we will find the belt selection using the table 14.14, where we can find the classification of V belts, nominal top width, nominal thickness, maximum recommended velocity in the page number 314. And then you can use diameter of the smaller pulley by Savarin's formula. You can find the value of diameter of pulley and diameter of driven pulley using equation 1 minus epsilon into di that we discussed in the previous slide. And after finding the pulley diameters, you can standardize it using the 14.22 table, and then you can calculate the belt speed, determination of center distance, determination of pitch length of the belt, and exact center to center distance is a new equation. C is equal to a plus root of a square minus b, and determine the angle of contact that we discussed in the previous question, determine the number of belts required, and specify the belt, which belt we are going to select, that we have to specify. Next problem, problem 5.4. Here this problem deals with design of V belt. Here two shafts 1 meter apart are connected by V belt to transmit 90 kilowatt at 1200 rpm of a driver pulley of 300 mm effective diameter. The driven pulley rotates at 400 rpm. The angle of groove is 40° and the coefficient of friction between the belt and the pulley rim is 0.25. The area of belt section is 400 mm square and the permissible stress is 2.1 megapascal. Density of the belt is 1100 kg per meter cube. Calculate the number of belts required and the length of the belt. Here for finding the solution, we have some given parameters, center distance and p-value, power, and nn, small d, ns, alpha, mu, a, sigma d, rho, n. We have to find n dash, number of belt, and l, length of belt. For finding n dash, we have a connecting equation between power and n dash. But in that equation, we have to find the value of V and theta. How to find the value of V? Here we have the equation for V and theta. Here we have the equation for P and N. For finding this, for substituting in this equation, we don't have the value of V and theta. To find the value of V, we have to substitute in this equation pi dnl by 60. You will get this value. And for finding the value of theta, you have this equation. Here capital D is not given. To find capital D, you have the velocity ratio. You can substitute the value of velocity ratio in velocity and diameter relation. You will get the value of capital D. Substitute that value here and obtain the value of theta s. And you need mu value also. How to find mu value? Mu value is equal to, you will obtain from 14.12. Mu is equal to mu by mu dash or mu s is equal to mu by sine alpha by 2, and you will get the value of mu equal to 0.731, and substitute here, you will get n dash is equal to 7.77, and you can approximate as 8 belts are required. And how to find number of length of belt? We have the basic equation is available in data book 14.2, and substitute that value here and you can easily obtain length of the belt. And this is the end of the lecture number 2 of module number 5. We will continue with the same module in the next video. Stay tuned. Thank you.